Welcome to this edition of Math Dive in About 5. Today we'll be focusing on the unit classifying two-dimensional figures. My name is Barbara Knox.
And I'm Daryl Frost. Welcome.
Here's your first task. We'd like you to pause the video and complete this task either on your own or with your team or partner. You're going to look at the shapes that are on the screen. There are 6 of them. You're going to decide what the defining attributes of each of these shapes is, and then name each shape based on those defining attributes. You'll also want to decide whether the shapes belong in more than one category. Good luck. Here we're going to look at the progression with the best standards, and even though geometry instruction begins in kindergarten, the formal language of defining attributes and all of that comes into play in 2nd grade. So starting in 2nd grade, they work on defining attributes. In 4th grade, they're working with angles. In 3rd grade, they're sorting quadrilaterals. So none of that is really new when we get to 5th grade.
So really then in 5th grade, it's basically that benchmark is an application benchmark.
It is an application benchmark.
It's taking all the defining attributes and then applying them to see if what categories, subcategories, if you will, can shapes be in and be shared with other shapes.
Correct. In 5th grade, they focus on triangles and quadrilaterals. The triangles is shifting from 4th grade to 5th grade. This video, however, is going to focus on classifying the quadrilaterals. Yeah.
So based on this slide, Barbara, here, I see that when we think about defining attributes, now we're being real specific. We need to think about parallel lines,
yes,
pairs of parallel lines. We also need to think about
right angles.
And we also need to think about
congruent
sides.
Yes.
So it's really 3 main attributes.
Well, you're going to also carrying over from 2nd, 3rd, and 4th grade, the number of sides and the number of vertices.
Yes.
When we're focusing on quadrilaterals, we're only focusing on shapes, polygons that have 4 sides and 4 vertices.
Yeah.
So one of the things that you're going to sort by are parallel line pairs. So if I look at this parallelogram, I can put sticks on opposite sides of that parallelogram, and then the space between those sticks should stay equidistant forever and ever and ever, because those lines are parallel. The same thing is going to happen on the opposite 2 sides. That those 2 sides are also parallel.
That equidistance is a vocabulary word that should be used in the classroom by the teacher and the students.
Another thing we're going to look at are right angles. So if I can take a square like a color tile, for example, and place it into the vertices, then I know that those angles are right angles. And the equal length or congruent sides are, the language in the benchmark itself says equal length, but we can also introduce that vocabulary term congruent. So if I look at this rectangle, one side is the same equal length as the opposite side of that rectangle. So our first category is quadrilateral. A quadrilateral is a polygon with exactly 4 sides and 4 vertices. The definitions that we're giving you came directly from the best glossary.
Yeah, that's what it says.
So if this is our category, Daryl, what would our subcategories be?
Well, our subcategories would be trapezoids, rhombi, there you go. Trapezoids, parallelograms, rectangles, rhombi, and squares. 5 subclasses, but they all fit within that main category because they all have quadrilaterals because they have those defining attributes.
Right. Now, if parallelogram were my category, I would have different subcategories.
You would have different subcategories.
So looking at the shapes from your first task, all of those shapes are quadrilaterals because all of the shapes that you were shown on that first task had 4 sides and 4 vertices,
which were the defining attributes
of a quadrilateral.
So we see that a parallelogram is a quadrilateral containing two pairs of parallel sides. That would be the defining attribute
of a
of a
parallelogram.
parallelogram.
A parallelogram is a subcategory of three different categories: polygons, quadrilaterals, and trapezoids. A parallelogram is automatically going to fit into each of those categories.
Okay, yes, because it has those defining attributes.
Yes.
Of each of those shapes. Okay.
Yep. The subcategories of parallelogram are rectangles, rhombi, and squares, because the defining attributes of rectangles, rhombi, and squares include the defining attribute of two pairs of parallel sides.
It could be they could have other attributes, but they include that attribute that defines a parallelogram.
Yes. And from your first task today, the following shapes are all parallelograms because they all have two pairs of parallel sides. Shape is rectangle.
So the next shape is a rectangle. The defining attribute is a quadrilateral containing four right angles. What does it mean by oblong?
Oblong where two sides are longer than the other two sides.
Oh, okay, all
Yeah.
right. Okay, because some may not have heard that vocabulary word
They
before.
might not have, Daryl. The minimal defining list for rectangle is that it's a quadrilateral with four right angles. Rectangle belongs to the following classes: polygons, quadrilaterals, trapezoids, and parallelograms, because the definitions of polygon, quadrilateral, trapezoids, and parallelograms includes four sides and four vertices, which a rectangle has. There are subcategories of rectangle, being a square. A square would be a subcategory because the definition for square includes a definition from the rectangles being a quadrilateral with four right angles. But a square has an additional defining attribute, which we'll talk about on the next slide. So in the rectangle list, you should have had two shapes from the beginning task, and that was shape A and shape B.
So this is why we say all squares are rectangles.
Yes, but not all rectangles.
But not all rectangles are squares.
The next shape is square. Daryl?
Okay, so is the defining attribute of a square a quadrilateral with four right angles and four equal side lengths, or we could say congruent, four congruent sides.
So it's the same as it was for a rectangle with the addition of the four equal length sides. A square is a subcategory of polygon, quadrilateral, trapezoid, parallelogram, rectangle, and rhombus. It is not, it does not have any subcategories itself. So here we have a square. It was the only one from your first task that fits into the definition of square.
So you think about the square, it kind of like is the big picture, so to speak.
It has a lot of names.
It has a lot of names. Yes, that's what I was trying to say. It has a lot of names. Yeah. So we have a rhombus here. A rhombus is a quadrilateral containing four equal side lengths or four congruent sides.
Correct. The rhombus is a member of all of the following classes: polygons, quadrilaterals, trapezoids, and parallelograms. What would it be a subcategory of?
Four equal square.
Yes, it is a subcategory of the square because the square also has four equal length sides.
Yes, and that's exactly. Yeah.
Right. So you had two shapes from your beginning task, shape B and shape D, that are both rhombi. So here is our definition of trapezoid. It is a quadrilateral with at least one pair of parallel sides.
Wait a minute. Isn't that different?
That is different.
Because with the maths, it was two.
Actually, with maths, it could have been the inclusive or exclusive definition.
Okay, but this is saying it with at least.
Correct. In BEST, they are using the inclusive definition of trapezoid, which means that a quadrilateral has at least one pair of parallel sides. It could have one pair or it could have two pairs, making all parallelograms, rectangles, squares, rhombi are also trapezoids. most people have been using the exclusive definition in the past, which is a trapezoid has exactly one pair of parallel sides. And those are still trapezoids, but now we're also including polygons, quadrilaterals that have two pairs of
It
parallel
changes the
sides.
subcategories.
It does change the subcategories. So it is a member of the polygon and quadrilateral classes, but it has all of these subclasses. We have parallelograms, rectangles, rhombi, and squares, which are now also
Because they have at least one pair
trapezoids
of parallel sides.
Correct. So from your original list of shapes, you should have included all except for one of them. You should have included A, B, D, E, and F. Shapes A, B, D, and E have two pairs of parallel sides. Shape F has exactly one pair of parallel sides.
But at least.
But they all have
have
at least one pair. Correct. So here we have the hierarchy using the best definitions of the quadrilaterals that we looked at today. Within that purple loop, you see all of those shapes that have four sides and four vertices. So they are all quadrilaterals, right? The trapezoid loop, the yellow loop, includes all of the shapes that are within that yellow loop, including the parallelograms, rectangles, squares, and rhombi. In the past, you probably only thought of those six shapes on the left being trapezoids because they had exactly one pair of parallel sides. But now all of those within that green parallelogram loop also fit into trapezoid because they have at least one pair.
So if I'm understanding what you're saying, within the yellow loop of this Venn diagram, if you will, they're all trapezoids because they all have at least one pair of parallel sides. Correct. That's a big shift.
That is a big shift. The green loop includes all of the parallelograms. Parallelograms include rectangles, squares, and rhombi as well because they have two pairs of parallel sides. The red loop are my rectangles, and within the rectangles I have a subcategory of square because squares fit the definition of rectangle, but they have one additional defining attribute of the congruent sides. Same thing with the rhombus, that blue loop. They're all rhombi. Square is a subcategory of rhombus because it also has the four right angles that a rhombus doesn't necessarily need to have.
Is it four right angles or four congruent sides?
They all have four congruent sides. Squares and rhombi have four congruent sides.
Four congruent sides, okay.
The subcategory square for rhombus is because it has the additional defining attributes of the right angles.
Got it.
Yep. Thank you for joining us for this edition of Math Dive in About 5. We'll see you back next time.